The final lesson before your first test of Unit 2, yes, I forgot to mention there are 2 tests in Unit 2, one that covers 2.1 to 2.3 and one that covers all of 2.1 through 2.5, is going to be solving systems of equation by elimination. That being said, this first test on 2.1 to 2.3, you will be expected to be able to demonstrate your understanding of solving systems of equations by both substitution as well as elimination. If on the test you choose not to use the method I asked you to use, you will be docked points because I need to see that you can do both. However, on the final test of the unit covering 2.1 to 2.5, we will let you pick your methods. Now, most people, after I teach this elimination lesson, find that elimination is their method of choice, but not everybody. So I want you to be able to use both, get practice with both, and then you make that decision. So first step when solving by elimination is going to be set up the equations so one term is opposite of the matching term in the other equation. What I mean by that, notice I've got a 3x and an x. That doesn't really work when I got a negative y and a negative y. So I say, oh, well, if I can multiply this whole equation by -1, then I would end up having my 3x minus y equal to -2, and I would have negative x plus y equal to +4. So then what I can do is I can add those 2 equations together. And the reason why I want my signs opposite is so one term eliminates. So 3x plus -x is going to be 2x, and -2 plus 4 is 2. So then I'm going to scroll this up for you. I'm going to go ahead and solve for the variable. So I divide by 2, and I get x equals 1. So then I'm going to do what we've talked about before, substitute into one of the equations. Now in substitution, you had a specific equation you had to substitute into because you had used the other one already. Here you can pick which one you want, and then finally make sure you check your solutions. So now that we have the x equals 1, I'm going to, just for the ease, I'm going to put it into the second equation because x is already just x. I don't have to do any multiplying. So that means I'm going to have 1 minus y equal to -4. I'm going to subtract 1, and I get -y equal to -5. And then I divide by -1, and I get y equals 5, which means that my solution is 1, 5. And if I check that, 1 minus 5 is -4. 3 times 1 is 3. 3 minus 5 is -2. So I know that it does check out.
Can we have a negative variable?
You can have a negative variable, just not for your answer. You can't leave it as -y equals -5 because that's the opposite of y, and we want to know what is y because we don't graph -y, we graph only positive. Good question. So now we look at this one. This one's a little bit messier. We want to turn the equation so the number in front of the variable will be the same, just opposite sign. So we could make the x's eliminate or the y's. I'm going to choose the y's because one of them is already positive and one of them is already negative. That means I'm going to multiply, and I say, okay, what can I turn y into? 3 and 4 both go into. Well, I say 12. So that means I have to multiply the top equation by 4, because 4 times 3 is 12, and the bottom equation by 3. That means my new equations are 20x plus 12y equal to 36. And the bottom one is 6x minus 12y equal to 14 times 3. 3 times 10 is 30. 4 times 3 is 12, so this would be 42. So now I can go ahead and add those 2 equations, and I get 26x. These cancel. And 6 plus 2 is 8. 3 plus 4 is 7, so I got 78. So then I'm going to divide both sides by 26. And I just so happen to know that 78 divided by 26 gives me 3. So then I can take that 3, and I'm going to put that x equals 3. I'm choosing the bottom equation again just because that 2 is smaller. So that means that I've got 2 times 3 minus 4y equal to 14. 2 times 3 is 6, so 6 minus 4y equal to 14. I'm going to minus 6, and I'm going to get negative 4y equal to 8. Divide by negative 4, and I get y equals negative 2, which means my ordered pair solution should be 3, negative 2. If I check that, I have 5 times 3, which is 15, 3 times negative 2, which is negative 6, 15 minus 6 is 9. 2 times 3 is 6, negative 4 times negative 2 is positive 8. 6 plus 8 is 14. So that's it for today. I know some of you are probably wondering, how did I get so lucky to not have any word problems? Well, word problems, it's not the solving the system, it's setting it up. So that's why I only taught it once. We'll work on it in class. If you can set up the system, you'll be golden. So I want you to give these two systems a shot, solving them by elimination, not substitution. Give that elimination a shot. And enter those questions you have into class meet, and bring your questions with you to class tomorrow. It's very important you put those questions into class meet, like I mentioned before, so that way we can have those questions to prepare, because we will not have a team test or an extra day of review before this first test.